fluid mechanics. Or you can say mechanical properties of fluid. What do you mean by fluid? Any substance which can flow is called as fluid. So it can be liquid or gas. Sakshi, you gave the test. Hello, Sakshi.
Yeah, sir.
Test you have given?
No, sir.
Why?
I'll give it today, sir.
So take care now. See, now there is no exam, nothing. Casual approach may when you come, na, even teacher gets demotivated. Then he feels that child is not interested. वो तो क्या parent ने fees भरा है तो forcefully बिठाते इसलिए बैठ जाते. So you should have some motto for that. Now otherwise, suppose your requirement is 120. You work very hard, you get only not working, you get 100. थोड़ा सा अच्छा करते तो ज्यादा मिलता ना. So when you are doing, do either the best or no need to. So please write the test.
Yeah, sir.
What is meaning of viscosity in fluid? Viscosity in fluid. See, any liquid which flows, liquid I'm talking of, it cannot flow indefinitely. It stops after some distance. That means if I consider liquid to be made up of different layers, these layers might be opposing the relative motion between them. So property by virtue of which relative motion between adjacent layer of liquid is opposed is called as viscosity, and force of opposition is called viscous force. Indirectly it is like friction in solids. So the property by virtue of which the relative motion between adjacent layers of liquid is opposed is called as viscosity. The force of opposition is called as viscous force or viscous drag. So, written?
Yes.
Types of flow of liquid. Types of flow of liquid. There are two types of flow of liquid. One is called as streamline flow. The flow in which different layers moves in laminar motion in a plane. It doesn't move here and there. And velocity is less than certain critical velocity. हर एक लिक्विड का एक वेलोसिटी होता है, उससे ज्यादा वो स्प्रेड होने लगता है किधर. So depending upon that liquid, if velocity is less, then it moves in a straight line without moving in opposite direction. That is called streamline flow. Each molecule at same point, different molecules at same point will have same velocity. मतलब एक मॉलिक्यूल गया, दूसरा आया, उसका भी वेलोसिटी सेम रहेगा. Velocity gradient means change in velocity with respect to distance between layer is constant in case of streamline flow. Right, streamline flow.
Sir,
Yeah.
different molecules at same.
One.
What is the
One. Just write this so that I can be clear and explain with diagram. At same point, different molecule at same point will have same velocity. Done? Written?
Yes, sir.
Now see what is meaning of this. Suppose this is one layer of liquid, this is second layer, this is third layer, and so on. And this is final layer. It is moving through a pipe. When the liquid is entering here, leaving from here, so some molecules will come at this point A. ये जाएगा, फिर दूसरा मॉलिक्यूल आएगा, तो हर एक मॉलिक्यूल का वेलोसिटी ये पॉइंट पे सेम रहेगा, इसका मीनिंग. ओके, हेलो हेलो.
Yes, sir.
If I consider point P, molecule will come and pass away. Then second set will come ना, तो हर एक का स्पीड वो पॉइंट पे सेम, उसको बोलते हैं velocity gradient. At same point, velocity of different molecule is constant. Next is turbulent flow. When velocity of different layers of liquid is greater than certain critical velocity, then flow is called as turbulent flow. When velocity of different layers of liquid is greater than certain critical velocity, flow is called turbulent flow. The velocity gradient is different for different layers. Velocity at same point for different molecules will be different. Indirectly turbulent में सब कुछ different ही रहता है. Velocity at same point for different molecules will be different. Right. Future? Nifty future? 9:30, 9:35. Done? Hello?
Yes, sir.
Yeah, okay. Now, Newton's formula for viscosity. Important. According to Newton's formula for viscosity, for streamline flow of liquid, the tangential viscous force, because force will be along the liquid, therefore it is tangential. F is directly proportional to the area of cross section of layer A, and velocity gradient dV by dx. That is, viscous force F is proportional to area into dV by dx. That is eta A dV by dx, where eta is a constant called as coefficient of viscosity. Right, Krishna Patel? So by viscous Newton's formula, viscous force F equal to eta A dV by dx. Yeah?
Done, sir.
will become FA dV by dx. So its SI unit is, this will be Newton second. See, force is Newton, this is meter square, meter per second. Force equals to Newton second per meter, Newton second, meter per second. Area is beta. F equals to A, beta A dV by dx. Therefore, F is in Newton. Okay. Yeah. अपना 35 में क्या ना 20 लगे थे. So meter per second, and this distance is in meter. So meter gets cancelled. Newton second per meter square. Again, this one, force is in Newton, area is in meter square, velocity is meter per second, and distance is in meter. So this will get cancelled. Therefore, Newton second per meter square. So SI unit is Newton second per meter square. Important for mostly they will ask dimension of coefficient of viscosity. Stokes law. When a spherical body, so this is only valid for spherical body like air drop, liquid drop, or gas bubble, and so on. So when a spherical body is either falling or rising in fluid, then viscous force acting on the body, comma F, is given by 6 pi eta RB. Write this much, then I will derive formula for terminal velocity. Okay?
Yes, sir.
Obtain, yes,
So
yes.
can you go back? I haven't written
What you have written?
the formula.
F equal to 6 pi eta RB. This is the formula.
Okay, thank you.
Because once I write, na, then I cannot bring it back. Nothing is written, then it can come. Obtain terminal velocity. I feel one numerical you can expect on this. Obtain terminal velocity. See, terminal velocity means at the end what is velocity acquired. At the end means then it will neither increase nor decrease. When a spherical body having density greater than density of liquid, when placed on this, then it will fall in the liquid due to gravity. That means its own weight.
Yes, sir.
And viscous force will be acting in upward direction, which will oppose the motion. Can weight increase or weight is constant?
It'll increase, right?
No, weight is constant. Mg is constant in the liquid. It will keep on falling. Viscous force will increase because velocity is increasing. Upthrust, which is called buoyancy, this will also remain constant. So velocity goes on increasing. Upthrust and mg are constant. A stage will be reached when upward force balances downward weight, then net force becomes zero and body moves with constant velocity. That constant velocity is called terminal velocity. At terminal velocity V, weight of body is balanced by upthrust plus viscous force. So weight means mg, upthrust is buoyancy, which is density of liquid, volume of solid immersed into g, and viscous force is 6 pi radius eta v. Any doubt till this first?
No, sir.
Just draw this rough diagram and write only this much, then I'm proving it. So this week, this theory and electromagnetism you have to concentrate. Theory of this chapter and electromagnetism. Electromagnetism का MCQ मत करना, because electromagnetism make perfect, that is your test on Monday.
Done, sir.
Everybody is done? Sakshi?
Yes, sir.
So weight mg and upthrust density of liquid, volume of solid immersed into g plus 6 pi eta r. Mg can I write density of solid into volume of solid into g? Can I write like this? Weight ka formula into density of liquid, volume of solid into g plus 6 pi r eta v. Any doubt? Hello? Any doubt?
No, sir.
No, sir.
Volume of sphere is 4 by 3 pi r cube into g, density of liquid 4 by 3 pi r cube g plus 6 pi r eta v. I can cancel this pi throughout. One r I can cancel. This is r square. So we get density of solid 4 by 3 r square g minus density of liquid 4 by 3 r square g is 6 eta v. So therefore 4 by 3 r square g common, inside rho of solid minus rho of liquid equals to 6 times eta into V. So from this velocity V is 4 by 3 R square G upon 6 eta into rho of solid minus rho of liquid. 2 3s are 6, 2 2s are 4. So velocity becomes 2r square g upon 9 eta density of solid minus density of liquid. This is formula for terminal velocity. Oh.
Done, sir.
Now we'll see what is Reynolds number. Reynolds performed number of experiments and found that critical velocity for streamline flow to become turbulent flow is directly proportional to coefficient of viscosity inversely proportional to density and diameter of the pipe. So this is nothing but Reynolds R, or you can say NR eta rho d, where NR is Reynolds number. By finding the value of this Reynolds number, we can draw conclusion regarding the type of flow of fluid. If Reynolds number is less than 1000, then flow of liquid is streamlined. Experimented is found on this. If Reynolds number is greater than 2000, then flow is turbulent. If Reynolds number lies between 1000 and 2000, then flow can be either streamlined or turbulent. So these three values you have to remember: less than 1000 streamlined, more than 2000 then turbulent. Between them it can be either. That's all.
Done, sir.
Okay. Next one. Equation of continuity. So we have liquid which is incompressible, that means density is constant, and streamlined flow. Then mass of liquid entering per second equals to mass of liquid leaving per second. So if A1, B1 are area and velocity at entry and A2, B2 are area and velocity at exit, then mass per unit time at entry is same as mass per unit time at exit. Therefore, mass is suppose entering per second. I take M1 P1 and this is M2 P2. Density is same, volume will keep on changing. So this is density into volume at entry upon time, density into volume at exit upon time. Volume means area into distance covered by liquid in same time P. This is same time T we are talking about. Same time T. Area into distance covered in same time T. What is distance upon time called? Velocity. So for streamline flow, by equation of continuity, A1 V1 is equals to A2 V2. Yes, clear? A1 V1 is A2 V2.
Yes, sir.
Okay, okay. Okay.
No, sir. 1 minute.
Okay. आराम से। तो theory बड़ा chapter है ये. We are doing pressure, we are doing viscosity, we are doing turbulent flow, we are doing after this Bernoulli's principle, then we'll be doing surface tension. But only 3 MCQs maximum will come from this.
Done, sir.
What is pressure due to liquid column? Yeah, pressure due to liquid column. H D G. This you know, pressure due to liquid column HDG. H means height of liquid. D means density of liquid. And G is acceleration due to gravity. What is actual pressure acting on the body? Actual pressure. It is always atmospheric pressure plus P due to height of liquid column. That means if the body is inside liquid of height h and a person is swimming, so pressure will be atmospheric pressure plus due to this liquid column. Copy 2 point again. आ गया हाँ आ गया हाँ अब देखो मैं तो लोअर साइड में रखते देने के लिए 850 को हाँ 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 तभी अपने पास वो था ना ऐसे ऐसे हाँ हाँ अभी अपन 875 पे रखते थे देने के लिए
Done, sir.
What is Pascal's law? Pascal's law for enclosed mass of fluid, pressure exerted at any point on the liquid is transmitted undiminished on any other part of liquid. That is, pressure acting at any one point is same as that on other. So F1 upon A1 is F2 upon A2. This principle is used in hydraulic machines. It is used to lift the car in hydraulic brakes and so on. Right, Pascal's law. Okay?
Yes, sir.
Bernoulli's principle. According to Bernoulli's principle, that for streamlining non-viscous and incompressible fluid, the sum of pressure, energy, comma, kinetic energy per unit volume, comma, potential energy per unit volume always remains constant. So kinetic energy is half mv square. If I divide it by volume, mass upon volume is called density, so it will become half rho v square. Potential energy is mgh. If I divide by volume, it will become rho gh. Pressure energy means energy due to force or work done. Now work done is force into displacement. If I divide this by volume, I get area into displacement. So force upon area is called pressure. So we can say that is pressure, which is pressure energy, plus half rho v square, that is kinetic energy per unit volume, plus rho gh is always constant according to Bernoulli's principle. Copy this line. For streamlined, non-viscous and incompressible fluid, the sum of pressure energy, comma, kinetic energy per unit volume, comma, potential energy per unit volume always remains constant.
Done, sir.
Since P plus half rho V square plus rho G H is constant. So if we divide throughout by rho G, dividing throughout by rho G, we get P upon rho G plus half V square upon G plus only H is constant. Here P upon rho G is called as pressure head and V square upon 2G is called as velocity head. H is called as gravitational head. So only important due to this different name assigned to different variables. So if they say find velocity head, indirectly you have to find V square upon 2G. Copy the 2 point again.
Done, sir.
No, sir, wait.
Okay.
Done, sir.
Third point, since P plus rho half rho V square plus rho G H equal to constant. So we can say therefore P1 plus half rho V1 square rho G H1 is P2 plus half rho V2 square plus rho G H2. At same height, H1 will be H2. So this will get cancelled. So we can say P1 minus P2 is half rho V2 square minus P1 square. That means when pressure reduces, velocity increases. Right. Next class I will solve MCQ only on this theory, and after that surface tension wala theory फिर उसका आंसर. So this week our target is to complete fluid mechanics, and your target is only revise theory and complete electromagnetism.
Done, sir.
Tomorrow can I keep your class at 12 o'clock?
Yes, sir.
12 o'clock is fine for everybody?
Yes, sir.
Yes, sir. Yes, sir.
Okay, bye. Thank you.
Thank you.
Thank you.
Thank you, sir.
Thank you.
Sir, doubts of paper का.
आर्यन मैं आपको ना इवनिंग में कनेक्ट कर